Hi and welcome to my channel. In this video we will go through a real-world example here. So our firewall here, this one, is connected directly to the internet. So here is the internet. Everything looks perfect until you realize internal users can't get replies back from outside. You've got internet access on one side, a router on the other. So here we have internet and here we have a router. But somehow packets go out and never return. So a packet starts here, take its way, this, and out to the internet. But it never comes back. In this video, we will look at a common mistake in real-world networks when the firewall faces the internet, but the LAN gateway is a router. So we have a router behind the firewall. We will explain why the firewall needs a static route to know how to send reply traffic back to your internal subnets. You'll see how a simple route can fix broken return paths, stop asymmetric routing, and bring your network back to life. So let's get in and make sure our firewall actually knows where home is. So first, a walkthrough here. So let's take a closer look at our network. So here, this is my management server, and this is my checkpoint gateway. Here we have a client, which is connected to a layer 2 switch. And this layer 2 switch is connected directly to the core switch, or a layer 3 switch or router. And this one is connected through this port channel. So we have port channel here and port channel there. And this layer 3 router is connected to our firewall here. So this client, let's add some IPs here to make it more clear. Got this IP. Okay, and here this client have its gateway on this switch or router or layer 3 switch. So let's make it clear that we have the gateway here. So this client has its gateway here, not on the firewall. And this is a very production network example. You have always some kind of routing behind the firewall for the internal networks. So now when the internal client tries to browse the internet, so this client, the packet leaves the client and goes to its gateway, the LAN router. So from this packet goes this way here to its gateway. The router forwards it to the firewall, since that is the path to the internet. And this router has its gateway, the firewall. So the firewall performs NAT, sends the traffic out, and waits for the reply. So far, everything looks good. But when the reply comes back from the internet, there's a problem. So let's try. Okay, let's open a web page here, like Google or something, YouTube, and you see nothing is happening. So a packet goes to the internet, but so the firewall knows how to reach the internet, but it has no idea where the 10.10.10 network is. So this firewall knows about this network. Okay, this is here, and we can add another 10. It's the same as the one. Let's do this 10.1.2.2, something like this. This sits here. So the firewall knows about this IP address. It doesn't know about this one, the 10.10. So why NAT isn't enough? Now you might be wondering, wait, the firewall is doing NAT. Shouldn't it already know how to reply? Not exactly. NAT only changes the addresses inside the packet. It doesn't tell the firewall where these addresses live. So let's see what really happens. So NAT changes addresses, not paths. When the firewall does NAT, it just rewrites the source or destination IP. So let's look at this image here. So we have the packet, our packet, which goes out from this client, has the source IP of 10.10.1.2 and say the destination, the Google DNS. After NAT, when NAT is done, the source is this one, the external IP of the gateway. So this IP here, which is connected to the internet, and the destination is the same. So that's it. NAT hides internal IPs, but it doesn't add any routing knowledge. So when the reply comes, so let's say that we are doing a ping to this 8888. When the reply arrives at the firewall as this is the source and this is the destination. Okay, this is the source and this is the destination. So the firewall reverses NAT. Okay, changing the destination back to, so when the reply comes, it comes, this is the source and this is the destination. And the gateway looks at its NAT table and changes this destination to this IP. So far, so good. Now, it must forward this packet internally. To do that, it checks its routing table, not the NAT table. Okay, so let's open our gateway here. And it will show route. It will check this table here. Okay, I have 10.1.2, it is not 10.10, and I have 192. So it says, I don't know where that network is. I'll use my default route. So it should use this way again. But the default route points to the internet. So the reply goes the wrong way and disappears. So NAT and routing are two different layers of logic. NAT changes packet addresses. Routing decides the next hop. So without a proper route, the firewall can translate addresses correctly, but still fail to deliver the packet. That's why you must add a static route to reach the internal subnet. So to fix it, we add a static route that says to reach 10.10.1, send the traffic to 10.1.2.2. Okay, so we need a static route that said, if you, to the gateway, if you get a traffic distant to this IP or this subnet, the 10.10.1, send it to 10.1.2.2. And now, after NAT reversal, the firewall knows exactly where home is, and the reply finally finds its way back to the client. So remember, NAT makes packets look right. Routing makes packets go right. So you need both for successful two-way communication. So let's head to the gateway. And I think this one. So this is the static route that we need. So set static route. If you get traffic from this subnet, the next hub gateway is this one. So the 10.1.2.2, as we can see here. So let's add that static route and try again. And now you see directly it is working. So that is a very short video about this example. It is from production, so you will see this all the time. If you forget to add the route, you will get that problem. So if this helped you understand the relationship between NAT and routing, leave a like, subscribe, and stay tuned for more deep dive network lessons. So this video is done here, so thank you for watching and see you in the next video.